Physics Part 205. Consider angle delta theta to be small, that the arc AB may be approximated to a straight line. Then using similar triangles, DE divided by CD is equal to AB over OA, and delta V divided by VA is equal to delta S divided by R, or delta V is equal to delta S into VA over R. The time to travel either the distance delta S or the angle delta theta is delta T, dividing both sides of the equation by delta T. Delta V divided by delta T is equal to delta S divided by delta T into V over R. And from the definitions of the acceleration, A is equal to delta V divided by delta T, and speed V is equal to delta S divided by delta T is equal to VA is equal to VB. We have A is equal to V into V over R, or A is equal to V square over R. This expression can be written in terms of angular speed, since V is equal to R into W. Centripetal acceleration is V square over R into V square, W square. And since F is equal to MA, centripetal force is equal to MV square over R and MR W square. We've got an example for you. The drum of a spin dryer has a radius of 20 centimeter and rotates at 600 revolutions per minute. A. Show that the angular speed of the drum is about 63 radians. Calculate the point on the edge of the drum. Number 1, its linear speed. Calculate its linear speed. Number 2, calculate its acceleration towards the center of the drum. Now it's your turn. A toy train moves round the circle track of diameter 0.70 meter, completing one revolution in 10 seconds. Calculate for this train A, the linear speed. Calculate the linear speed. B, calculate the angular speed. C, calculate the centripetal acceleration. Examples of circular motion. When a ball is whirled round on the end of a string, you can see clearly that the string is making the ball accelerate towards the center of the circle. However, in other examples, it is not always easy to see what force is providing the centripetal acceleration. A satellite in Earth orbit experiences gravitational attraction towards the center of the Earth. This attractive force provides centripetal force and causes the satellite to accelerate towards the center of the Earth. And so it moves in a circle. We shall return to this in detail in chapter 11. A charged particle moving at the right angles to the magnetic field experiences a force at right angles to the direction of the motion. Therefore, moves in the arc of a circle. This will be considered in more detail in chapter 12. For a car traveling in a curved path, the frictional force between the tires and the road surface provides centripetal force. If this frictional force is not large enough, for example, if the road is oily or slippery and the car carries on moving in a straight line, it skids. A passenger in the car that is concerning appears to be flung away from the center of the circle. The centripetal force required to maintain passenger in a circular motion is provided through the seat of the car. This force below the center of the mass passenger causing rotation about the center of the mass. The effect is that the upper part of the passenger moves outwards unless another force acts on the upper part of the body, preventing the rotation.